Soil covers the majority of the land on Earth, serving as the planet's skin. It is the reason why plants and trees are tough and difficult to harvest. Insects, worms, and other burrowing animals live in soil as well. It is made up of water, air, minerals such as rock, sand, clay, and silt, as well as organic matter from dead plants and animals. Soil is formed over long time periods. A single inch of soil can take up to 1,000 years to form. Soil is composed of 4 components: rock fragments, dead and living organisms, water, and air. The parent material, which is usually a large rock, is broken down into smaller pieces by rains and winds. Rocks can be weathered in 2 ways, physically or chemically. Physical weathering occurs when the rock is weakened and disintegrated as a result of physical forces such as temperature changes, friction, freezing, or heating. Chemical weathering occurs when a rock is weakened and disintegrated as a result of chemical reactions that alter the mineral composition of the rock. Chemical weathering processes such as oxidation, hydrolysis, and carbonation can either form or destroy minerals. When rock minerals react with oxygen, oxidation occurs. Carbonation occurs when rock minerals react with carbonic acid, a chemical formed when water and carbon dioxide combine. Water causes a chemical reaction known as hydrolysis. Water changes the chemical composition and size of minerals in rocks, making them less resistant to weathering. Agents work their way through the parent rock, reducing it to tiny soil particles. Wind, water, plants, animals, and the sun's heat are all examples of agents. The weathered fragments are broken down even further into smaller pieces to form sand and silt, and then even finer particles. Soil is formed when organic matter decays and combines with rock fragments, minerals, and water. This slow process continues indefinitely, and the fine particles form the top layer of the soil. Plants, fungi, animals, and bacteria all contribute to the formation of soil. The area's topography is defined as the slope of the land's surface where soil forms. The climate has a significant impact on soil formation. The type of rock disintegrated to form the soil has a significant impact on its formation. This type contains 25% clay. Clay particles are extremely fine and bind extremely well. This type of soil retains a lot of water. It remains wet and cold in winter, making it very sticky and dry in summer, making it as hard as a rock. It has few air spaces and thus does not drain water well. Clay is typically formed where the parent rock comes into contact with water or steam. This is a light, warm, and dry type. Sand drains water quickly and is relatively simple to work with. It has the largest particles, but they are fine and hard, and it has a very gritty texture. It is poor at retaining water and quickly warms up in the summer. It is deficient in nutrients because these nutrients are washed away. Weathering of shale, limestone, granite, and quartz produces particles. This soil is light, retains moisture, and has a high fertility rate, allowing plants to be grown in it. It is made up of medium-sized particles that are finer. This soil is easily compacted and is easily washed away by rain. When fine sediments such as dust, organic matter, and debris are carried by water and deposited, it forms. Siltstone is formed when this soil is deposited and cemented over time. It is made up of sand, clay, and silt particles. It has excellent water retention, calcium retention, and aeration. Most crops and vegetables thrive in this soil. It is soft and very easy to grow. This is regarded as a gardener's best friend. It has a very dark color. This soil is rich in organic matter and holds a lot of water. It is rarely found in gardens naturally, but it is commonly used as a soil base for planting. It has an acidic nature, which causes decomposition to stop. Chalky soil can function as either a light or heavy soil. Because of the presence of calcium carbonate or lime, it is always alkaline, with a pH of 7.5. It has a stony texture and a limestone bedrock. Because of its texture, it drains freely. This type of soil does not support the growth of acidic plants due to its alkalinity. This soil is not ideal for gardening because it lacks iron and manganese. Soil has various layers that are arranged, and these layers are referred to as horizons. A soil profile is the sequence of these horizons. The color and particle size of the horizons are observed. The soil layers have different characteristics, and these characteristics determine how the soil is used. A mature soil consists of 3 complete layers: topsoil, subsoil, and parent rock. An immature soil has only 2 layers. Horizon O, or the organic horizon, is a thick layer of plant remains composed primarily of organic matter, leaves and twigs. Horizon A, or topsoil, is 5 to 10 inches thick and made up of organic matter and minerals. Topsoil is home to plants and organisms, and it is also where seeds germinate. Horizon E, also known as the alluviation, leaching, layer, is mostly made up of sand and silts. Horizon B, also known as the subsoil, is very mineral-rich because it accumulates minerals that have moved down from the A and E horizons. Horizon B is primarily composed of clay, iron, and organic matter. Horizon C, also known as the regolith, is the surface from which the soil or upper layers developed, and it is mostly made up of massive rocks. Plant roots do not penetrate Horizon C, and there is very little organic material in this layer. Horizon R, the final horizon, is also known as the bedrock. Horizon R is a large mass of unweathered rock composed of granite, basalt, quartzite, limestone, or sandstone. Soil is the only substrate on which plants can grow. They provide an effective filtration system for surface water, which is why underground water, aquifers, is thought to be pure and clean. Many organisms live there, and they help to create a suitable environment for plant growth. It helps to keep atmospheric gases in balance by regulating the amount of carbon dioxide in the atmosphere. A soil scientist is known as a pedologist.